In this video, I'll be talking about a LeetCode problem called next permutation. We have already talked about permutation calculation in a separate video, so I'll link that video in the description box below, so you can check out that video if you feel like understanding what permutation is, because we have discussed permutation in quite detail in that particular video. But in this problem, let's look at what is required. So a permutation is basically a arrangement of numbers, of given numbers or given characters in a particular sequence. But in this problem, we are dealing just with the numbers. So let's take an example of numbers as 1, 2 and 3. As you can see, these are all the permutations which can be created out of it. If you have three numbers, 1, 2 and 3, the number of permutations will be 3 factorial is equal to 6. So just let me list them down quickly here. 2, 3, 1, 3, 1, 2 and 3, 2, 1. Now what is required in this question is that given any particular permutation out of these, we have to find the next bigger permutation. So we have to find the minimum number which is bigger than a given permutation. For example, if 1, 2, 3 is given as an input to us, the next bigger number than 1, 2, 3 is 1, 3, 2, as you can see. So this is the next permutation, and this is given 1, 2, 3 as input. We are expected to output 1, 3, 2. If 1, 3, 2 was given as an input, so our output will be 2, 1, 3, because that is the next biggest permutation, or the minimum number which is bigger than 1, 3, 2. If we are given 2, 1, 3 as input, then we are supposed to output 2, 3, 1, because that is the minimum number which is greater than 2, 1, 3. If we are given, similarly, if we are given 2, 3, 1, the next permutation will be 3, 1, 2. If we are given 3, 2, 1, since we don't have any permutation which is bigger than this, so we have to output 1, 2, 3. So this is a special case which needs to be handled. So which means that if you have reached the end of your permutations and you are given that last permutation as an input, you are supposed to go back and give as an output the first permutation which can be formed out of the given array. If you look at the signature, so we have nums as the array which will be given, which means, for example, if it is 3 numbers, it will be an instance of array can be 1, 2 and 3. And then if you look carefully, the output is void, which means that we are expected to rearrange the given input array into our output. If 1, 2, 3 is, which means that if 1, 2, 3 is given as an input, we have to rearrange the same input array to 1, 3, 2. If we are given 2, 3, 1 as an input, we are supposed to rearrange the same array and give 3, 1, 2 as an output. If you notice, this requirement is given in the last line just before the examples, which says that the replacement must be in place, which means that we have to modify the input array which is given to us and not return any array. And then we have to use a constant extra memory, which means that we don't have to use any new array and manipulate that and change the input array itself. So this is what the question is all about. Now we'll look at the solution. In any given number, for example 1, 2 and 3, there is a concept of least significant bit and most significant bit. If you want to find a number which is greater than 1, 2, 3 and which is just greater than 1, 2, 3, I mean a minimum number which is greater than 1, 2, 3, then obviously you have to look at LSB and start looking from LSB towards MSB. What I mean is, if you directly look at MSB, then you might be tempted to convert 1, 2, 3 to 3, 2, 1, which is bigger than 1, 2, 3, but it is not the minimum number which is bigger than 1, 2, 3. Now, if you start from least significant bit, which is 3, then you will see that you can convert or swap 2 and 3 here, and you will get 1, 3, 2. and in this case 132 is the minimum number which is greater than uh, 123. So what I want to say is that it is obvious that in order to find the next permutation, we will have to start from LSB and move towards MSB, or from right to left. So that is one important point to keep in mind when we solve the problem. So let me just note it down here. So we have to move from right to left direction. That is one thing. Now just consider these two numbers 1 and 6. So here you see that 1 is on the left hand side of 6, and if you swap these two numbers you will get a number which is bigger than 16, so you get 61. So what I want to depict here is that we should be interested in looking in finding such combinations where we have a number and to its right there is a number which is bigger than this bigger than 1. So if you have bigger than the number on the left, so the right number to the right should be more than the number on the left, because if you get such a combination, when you swap it, then you have a chance of getting a bigger number. So in this let's look at one more example, 2 3. So now if uh, the number to the right of 2 is bigger than that, so we can swap them and we get 32, which is more than 23. If I had started with 32 and if I swap them, then I get 23, which is not the combination I'm interested in. So the number on the right of a particular number is less than the number on the left. So we are not really interested in such numbers. We are interested in numbers in which the number to the right of a given number is more. With this thing in mind, also let me write down this point because it is important point to find the solution. So find a number that has greater than this number to its right. So this is an important point. And the index at which this occurs, so the index at which I get a number that has a greater number than it to its right, let me call that index as a pivot index. So this is a pivot index, and then we will derive our fourth point when we look at example. So now with these 3 points in mind, let us start looking at an example. So we'll take a little big example than the trivial example here. So 7 8 4 6, then 5, then 3, then 2, and then 1. So we start our calculation and we start from right and move towards left. So since 1 is the first number, we can simply not do anything. Then we will come to 2 and look at its right, and we see that there is a smaller number to its right, which is 1. And as we saw here, we are not interested in such combinations. So now let's move to 3. Again 3 has a number 2 which is to its right and it is smaller, so I am not interested. Now we move to 5 and we see that to its right there is a number smaller than 5 and I am not interested. Now we move to 6. Again to its right there is 5 which is smaller than 6 and I am not interested. Now again I move to 4, and at this point I see that the number to its right is bigger than 4. So 6 is bigger than 4. So this is my pivot index, you can say. And now we have to see what we have to do with this pivot index. So 4 is, if you look to the right of 4, you will see that there are some numbers which are greater than 4, which is 6 and 5. And then there are some numbers which are less than 4, which are 3, 2, and 1. So now I am interested in finding the minimum number which is to the right of 4 in this direction, and it should also be greater than 4. So 6 is to the right of 4 and it is greater than 4, but then there is also 5 which is to the right and greater than 4. So at this point, and after that there is 3 which is less than 4. So I am interested in now 5, because it is the minimum number which is to the right of 4 and it is also greater than 4. So with these, when I have this finding of two indexes, which is 4, the index at which 4 is there and the index at which 5 is there, I will simply swap them. So that is the first part which I have to do. So I'll swap 4 and 5, which means that I'll get to this state that I'll have 7, 8, 5, 6, 4, 3, 2 and 1. Now what we have to, there is one more thing remaining. So first maybe I can just write it down, the step we just performed. Swap pivot index number with smallest number greater than the pivot number, and this step is already done here. Now we have to focus our attention to the numbers which are to the right of our pivot index, because the pivot index still remains this. We have just swapped the value. Now we have to focus our attention to this area. So if you look carefully, we have the numbers in a descending order. So they are already sorted but in a descending order, and as you might have guessed, we have to find the smallest number which is bigger than the given input. And in order to do that, we simply can reverse this order. And if we write it down in this way, which means that if we just swap this index, and this index, we will have something like 1, 2, 3, 4 and 6, which means that we have simply reversed the direction from here, from this direction to this direction, and we have this number now. And if you look closely again, this is the minimum number which is bigger than the given input, and it is also a permutation. So this is the result we are looking for, and this is the answer. And this is the last step, which is to reverse the numbers after pivot index, which is this step. And with this we come to our next permutation of a given input. Now I hope that it was clear, and let's now look at the complexities. So as you have seen, we are just manipulating a given input array by swapping the numbers. So and we are just going through this particular array once, and maybe in order to reverse it, we are going over it once more. So we can say that our time complexity is on simply, and that was a requirement in the question also, that we had to do this in place. And as far as space complexity is concerned, it is again a constant space, because we did not take any new array to do this calculation, and we just swapped our values by using a temporary variable, which is a normal way to swap the number. So again, in this case, our space complexity is O1. So now with this background in mind, we will be looking at our code, which should be fairly easy to translate from this particular solution to code. But before we go there, if you have enjoyed the discussion till now, please like this video and put in your comments as to what can be improved, or what did you like about this discussion. And also please subscribe the channel if you want. So now let's look at the code. So this has been written in Java, but if you follow the code walkthrough which we are going to have now, you should be easily able to translate this into any language you like to. So let's start with our walkthrough. So there are four methods in which the entire solution has been divided. So let's look at each of them. So first let's look at some of the trivial methods which perform some very basic operations. So first let's look at the swap method. So it gets an array as an input and two indexes, and it simply swaps the values which are present at those locations. So if example for example, if you have 132 as an input array, and if you are given indexes as 0 and 1, it will simply swap the numbers, which means that 3 1 2 will be the output because it swaps these two numbers. Now let's come to this reverse routine. So again, it has this array as an input, then it has a start index and an end index, and it simply reverses the numbers which are present between start and end. So if you have 1 2 3 4 as your input array, and then you have start index as this and you have end index as this, which means 2 and 3, what it'll do is it'll simply reverse the numbers. So the output will be something like 1 2 4 and 3. So it reverse uses swap. So how it does the conversion is, if for example you have 1 2 3 4 5 and you have to reverse the entire array, so what you will do is first reverse these two positions, and then you will reverse these two positions, and then 3 will be written as such, and at the end you in effect reverse the entire array. So this is what it does by calling swap repeatedly, by increasing the left pointer and decreasing the right pointer. So this is what the reverse method does. Now let's look at the find pivot method. As we discussed in our discussion, that given a array, we have to first look for a pivot index, and we have to start from right to left. So that's why, if you notice carefully, we are initializing I with the last index of the array, because we want to move from right to left, and then it's greater than 0 because we are checking for I minus 1, so we do not want to go beyond 0. So that's and the condition is that we are looking moving from right to left, we are looking for a number which is, and the right number should be greater than the number on the left, or the left number should have a greater number to its right. So it iterates over the array, and at first such occurrence it returns that index. If for example there is a case where it is not able to find such index, which can happen in cases like this, where you have a continuously increasing number from as you go from right to left, in that case we simply return -1 from this find pivot, which is a special case that we have to handle, which I also discussed during the discussion of the problem, saying that if these are the permutations, and if you are given this permutation and you are supposed to find the next one, then this one will be the next permutation. So this particular -1 handles this case. Now let's look at the next permutation method, which is the actual method which we have to code. So it has this nums array which is given as an input. The first step which we have to do is to find the pivot index, and we have already looked at the details of this find pivot method. Let me rewrite the example which we looked at in the breakdown. 5 3 2 1. So we have already found that the pivot index is this particular index, the second index, and then if pivot is equal to -1, which means that we are talking about a case where all the numbers are increasing as we go from right to left. In this case, the pivot will be returning a value of -1, and in such cases we simply have to reverse the entire number, which means start from 0 and go till the end. So 3 2 1 will become 1 2 3, which will be your next permutation. So this is how the special case gets handled. Now let's move to the normal cases where we have a pivot index somewhere in between, what we will do is we'll start, once we have the pivot index, again we will start our iteration from right to left, and we will look for the first number which is greater than the number at the pivot index, which is 4. So 1 is not greater than 4, 2 is not, 3 is not, and 5 is greater than 4. As soon as you find 5, which means that you have satisfied this condition, that your pivot number is less than the number in the array, which means this is 5 and this is 4. In such as soon as you reach such a condition, you will swap these numbers, which means that you will swap 4 and 5. So you will have 3, 2, 1, and then the only work which is remaining is to reverse the numbers starting from the index which is greater than a pivot, which means that from here till the last. So you will simply have to reverse, and again we have looked at the reverse, and then as soon as we reverse, the state of the array will be something like this, which is your solution also. We'll simply break out, and we will end, and our nums, the state of our nums array will be something like this. So with this we have completed the walkthrough also, and I hope that you were able to understand the breakdown of the problem as well as the code, and you should be easily now able to code this in your favorite language, your IDE, and then run it and get it working. So that's it for this video. Hope you liked it, and we'll meet in some other video. Thank you.